Hi, my name is Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. Today we're going to talk about Rulon, and specifically, how do I pick the right Rulon for my application? Rulon is one of those materials that is almost generic in some ways, in that people automatically assume that Rulon is one material only, and that's the material that they happen to have in their hand. A lot of people think that Rulon LR, which is the maroon material, is the only Rulon that there is. Fact of the matter is that there's probably over 300 Rulons on the books, but in fact what we're talking about today is working with the top 15 or 20 materials, which are all represented right here on this little reading of materials samples. These are the materials that will answer about 98% of the applications that come up when you're talking about using a PTFE filled bearing grade material. Now, the thing you need to know about Rulon is that is exactly what it is. It is a PTFE material that has various fillers in it. And it's the amount of filler and the type of filler that makes these Rulon materials so unique. But there are some basic questions that we work with our customers on asking to be sure that they're making the right choice for Rulon material, because there are so many to choose from. It would be easy to say, well, you can just use Rulon LR for everything. Fact of the matter is that you can't, because there are some restrictions on where you can use the LR material, as is with Rulon J and Rulon 641 and all of the Rulons. There are so many Rulons because there are some parameters that are applied that sometimes can cause one of the Rulons not to function properly. So what we're going to do today is kind of walk you through the process of picking the right Rulon, or at least understanding which direction you should go when you're considering Rulon materials, or any plain filled PTFE bearing for that matter. First thing we want to ask is, what's the application function? Is it a bearing? Is it a seal? Is it a gasket? Because some of these materials can be used for all three of those applications. So, what basically are you going to be doing with that particular product? Secondly, what is the temperature? Now, all Rulon materials are capable of operating from -400 to plus 550, and a few of them can even go a little bit higher than 550. And because of that, we want to know a little bit more about the temperature conditions. And this goes back to plain bearing design, is what is the normal operating temperature going to be? And then secondarily, what is the temperature variation going to be, minus and plus? And again, we want to know that because for design purposes, we need to know how much press fit and how much close in to account for across that thermal gradient. Thirdly, we want to know what the environment is. Some of the Rulons are made to be in FDA type or USDA type applications, where many others are not. Some of the Rulons are capable of withstanding more abrasion than other Rulons. There are a few Rulons that are made specifically for freshwater applications. Most PTFE type bearings don't do well in water, so it's important that you select the Rulons that are in fact capable of functioning in water. Next is, what is the speed going to be? All of the Rulons, for the most part, can take upwards of 400 to 500 feet per minute, and that's unlubricated. The parameter that needs to be considered along with that speed is, what is the load? Because again, with any plain bearing, you have limitations on your loads, your speeds, and then the combination of those two issues. So we want to know a little bit more about exactly what the speeds are, and then what type of speed is it? I mean, is it a rotary, oscillating, or linear? This goes back again to plain bearing design. Those different forms of motion will generate different forms of heat, and it's how long is that heat being held in place that can affect the performance over the long haul of a Rulon bearing. Next, what are the loads going to be on that bearing? Most of the Rulons are capable of taking about 1,000 psi load, and that's in a static P rating. Others can take a little bit higher. It depends on the type of bearing it is, where it's located. Bonded bearings you can take to slightly higher load carrying capabilities. So again, we try and design around that 1,000 psi rating, but there are some variances that we can introduce depending on the type of application. Hardware. What type of hardware are we dealing with here? And again, this has to do with temperature and heat generation. If you're dealing with stainless steel, there are only a few of the Rulons that are capable of working against stainless steel without abrading it. Those particular materials do pretty well in heat. For instance, the Rulon 641 and the 1439, these are FDA type materials that are used in food and pharmaceutical packaging and processing. Do very well against stainless. They're very, very kind to the stainless. However, they do tend to, like all filled Teflons, they do tend to have different levels of heat holding capabilities. And so we need to take a look at those when we're talking about press fits and thermal expansions and running clearances and all that. So hardware is critical. Again, what type of metal is it? Or is it going into another plastic? That introduces a whole new area of problems. What is the surface finish of the mating hardware? For Rulon bearings, we recommend 8 to 16 RMS on the shaft or whatever the dynamic surface is. And for holding purposes, we'd like to see at least a 32 in the housing bore or whatever the holding mechanism is for your application. So those are very critical as well. And then finally, lubrication. Rulon is a self-lubricating material. As with self-lubricating bearings that we talk about in other tech talks, Rulon bearings are really designed to run without lubrication. It kind of defeats the purpose of having the migratory capabilities of the PTFE. That is your lubricant in a Rulon bearing, is the PTFE. And that is accomplished by letting it run dry and letting the different materials transfer that particulate into the mating surface so that you can generate a film. And it's that PTFE film that ultimately becomes your lubrication source for the long haul. The addition of lubrication basically blocks that from happening, and in fact you run the risk of adding debris to that lubrication, and that debris turns that grease or that oil into a lapping compound. And the Rulon materials are fairly soft when compared to other polymers, and so you can just imagine how quickly these bearings are going to wear out if you introduce abrasive compounds to it. So those are some of the basic parameters that we look at when we're thinking about Rulon for bearing applications or for seals or gaskets or even structural applications. Temperatures, loads, speeds, environment. The Rulons are all pretty much chemically inert. There's a few that have some problems with acids. But for the most part, Rulon, being a PTFE-based material, is chemically inert, so you can utilize it in just about any part of the pH scale. As you consider Rulons, again, we have several different versions of Rulon to select from. TriStar is proud to be the largest distributor of Rulon stock shapes and the only North American distributor of Rulon bearings. And we carry a large inventory of these materials, and we certainly have a great deal of affection for the material and capabilities in terms of specifying the right product for your application. So next time you want to consider Rulon, take into consideration these basic parameters that we look at, and then contact TriStar at our website, either through Ask the Expert or through our bearing or structural component checklist. And we're more than happy to then help you be sure that the determination is made for the right Rulon for your application. Thanks again for joining us at Tech Talk, and we look forward to seeing you again.